Let's start. We have the recording ready. Let me just share my screen. So you can take a snapshot of this ताकि you can include it in your discussion points. इसका पिक्चर ले लें. मैं इसको कर रहा हूँ डिलीट. अच्छा एक मिनट. Importing. Yeah. तो ऑलरेडी सिंगल बना. हाँ सिंगल ऑलरेडी बना. So not every website supports PSpice, right? But you will find LT Spice codes, right? Even if you have just a Spice code का model available, .lib files, you can use those in your importing method, right? Make sense? Procedure is same. There's some delicacies over here, okay? So again, let me just take you to a tour over here. Go to EPC website over here. So you will see के what they are manufacturing right now, right? So EVs pro AI आ गया, सब कुछ आ गया, right? Everything is there. अच्छा AI के अंदर we need smaller chips, right? Because they are transported in your brains. So it's again taking a turn in different domains that is rising up in the future, right? So AI भी boom आ रहा है, so it's everything. So again, they are against MOSFETs, right? So they have a huge marketing campaign against MOSFETs here because they are basically marketing their campaigns, right? Okay, so you can start designing. They will guide you step by step. Okay, how do we choose a particular IC, right? You can also find the product like in Texas Instruments. They have some curves of efficiencies, power losses, which you can explore over here. Assembly के लिए they basically guide you. They also have PCB के guidelines. कि how should be your PCB or gallium nitride MOSFETs, and about their basically history right over here, and some GaN properties. In the end, they also have active YouTube channel also. Okay, I told one of you guys, Asad को याद है मैंने, कि they have basically monthly or bi-monthly talks on YouTube on different topics, right? On gallium nitride. So you might find also design discussion on half bridge ICs also over there, right? They talk about efficiencies, they talk about trends over here, right? So on and so forth. And they are the actual engineers which are working in the company, right? Not just any person here, right? So again, if you go to products, they have basically GaN FETs and ICs. तो उनको लोगों ने divide कर दिया है property voltage wise. Again, why is GaN not getting used in sort of every field? Because of its voltage restriction, right? Its maximum voltage is around 350 volts. You can see over here, right? But if you talk about electric vehicle powertrain, so the voltage goes around 800 volts. Okay, so it is getting used in the low power zone over here. But again, that's the future, right? They are developing the ICs. So soon, after 5 years, 4 years, they will be there, right? AI के अंदर again, you are basically transplanting chips, MOSFET, right? Everything contains a MOSFET, right? Even the computers, the converters, everything we have basically MOSFETs are over there. So in AI, they're using to basically read minds also, right? So in the mind, how can you fit in a silicon MOSFET, right? Okay, they have a module made which have to be compact and small, right? So that is why they're targeting AI right now. They are used. You can search about it over here. So they have evaluation boards. Okay, they have ready-made boards. You can just buy it and test it. Okay, क्या properties हैं, ठीक है? Use it on your systems, so on and so forth, right? अभी हम कहाँ पे थे? EPC 2010C. ठीक है? So over again, if you go scroll down, so we'll see the data sheet, right? So just open this. You will see the evaluation boards which are using these MOSFETs, right? Which you can buy and just use it directly. You can see their quality reports, qualification reports, reliability reports, ROHS. There are some basically industry standards which you want to basically analyze. Again, then they have the wide variety of resources available for simulation, right? They support T-Spice, LT-Spice, T-Spice, Petre model, LTM library, which use basically create PCB models, right? PCB designs. Gamma model भी इसका available होता है कि how does it affect according to temperature, right? So realistic modeling available है. Step मैंने explore नहीं करा. Step is also one of the softwares, right? So just download the LT Spice sorry, not at tSpice over here.
हमने APC 205
मैं आपको वो बता रहा हूँ, आपको करेंगे।
दिया,
अच्छा,
लेकिन उसका नाम अलग शो हो रहा है।
हाँ, so
It's
just
APC 100।
अच्छा, मजे की बात ये है कि if you can just import can library once, you can access all of the part के names. मतलब with a single symbol, you can import any model of the MOSFET. EPC 205 तो अगर आपने कर लिया import, you can use 2010C, ठीक है, because library के अंदर it has defined all of the MOSFETs. Make sense? You just have to change the name of the MOSFET. ठीक है। अच्छा, so अभी हमने डाउनलोड कर ली है, so let's go towards the folder EPC can. So take it in your directory over here, जहाँ पे सेशन 2 है हमारा।
मैं वही कैन वाला यूज करूँ जो मैंने इंपोर्ट किया।
हाँ हाँ, you can change the name easily. जो आपके पास लाइब्रेरी है कैन की, it has the spice code for all of the MOSFETs.
कहाँ पर
खोलें लाइब्रेरी फाइल्स,
कोई और फोल्डर नहीं है?
बता दो, follow my instructions. So you have the EPC can का folder over here, right? You will again traverse again to the folder. You will see इसका symbol भी defined है LT spice का. That is pretty realistic, right? MOSFET वाला look दिखता है हमारे पास. You have the library here. You have an example also which they have basically given you कि हम लोग कैसे इसको इस्तेमाल कर सकते हैं, right? And some text document to explain कि हो क्या रहा है इसके अंदर. So if you open the library, open your LT spice. So you open your LT spice and open the library. So इसके अंदर जहाँ पे open all files. So if you traverse through the library, you will see all of the MOSFET's key parameters are defined over here. Just scroll down and see. It's a huge code, by the way. Right? So यहाँ पे EPC 2001 defined है. यहाँ पे 2101 Q1 भी है. Right? Again, the names are defined over here. You can see it includes all of these MOSFETs here. Okay, it includes all of these MOSFETs here.
Great।
Just see this. It includes all of the MOSFETs.
वही कह रहा हूँ 100
हाँ, ठीक है। So this is again a simpler trick. Once you have imported this library once, you will just have to change the name of the sort of the symbol, right? तो वो उस वाली प्रॉपर्टी को फेच कर लेगा from the library. Make sense? ठीक है,
कुछ सब सर्किट लिखा हुआ
ये देखे ना, ये बेसिकली एक पूरा कोड है फॉर 2001 टिल हियर ऊपर तक, ठीक है। ये एक आईसी का पूरा पैरामीटर डिफाइंड है।
मैं अलग अलग इंपोर्ट करूँ?
नहीं, यू विल जस्ट हैव टू बेसिकली इंपोर्ट इट वंस, ठीक है। मेक सेंस अदीर एंड आयशा, ठीक है। सो जस्ट क्लोज दिस। सो इसके अंदर यू हैव द सिंबल डिफाइंड हियर। अच्छा, इसके अंदर यू हैव टू डिफाइन द पाथ, ठीक है, बिकॉज ये इसके डिफॉल्ट सिंबल ओवर हियर, इसके अंदर पाथ डिफाइंड नहीं है जहां पे आपने सेव करा है अभी, राइट। सो हाउ टू डिफाइन द पाथ? ओपन एनी वन नोट फाइल, नॉट वन नोट, नोटपैड। हाँ, so you will have to open the directory path here. ये मैंने पहले के सेव करे हुए हैं कुछ applications.
आपने अभी उस पर राइट क्लिक करके सिंबल पे
हाँ, so this is the entire path, right? And आपने इसका नाम भी डालना पड़ेगा यहाँ पे। इसका नाम क्या है? This is this dot lib.
नेम ऑफ इंडिया।
यहाँ पे बना दिया।
क्रिएटेड वही है
और कितनी करना होगा? फोल्डर जहाँ पे नोट किया है।
थोड़ा
हाँ। ये तो बराबर इतने स्टैंडर्ड।
अच्छा इसको इसमें खोल।
हाँ
किस पे?
हाँ, तो कॉपी ऑफ पाथ ओवर हियर ना नोटपैड फाइल यहाँ पे आपके पास लाइब्रेरी अवेलेबल है कैन वाली
ये नोटपैड हमें इसमें बनाना है, इसके अंदर।
हाँ हाँ नहीं नोटपैड आप बस लिखना है सेव वर्ड फाइल पर भी ठीक है। अब जहाँ पे आपकी लाइब्रेरी है वहां का पाथ कॉपी करें।
ये वाला?
हाँ and in the end you want to include the name of the library with the extension name, right? ये पाथ हमारे करना है।
Wait.
The name of a library with the extension, not lib. Correct. बिल्कुल सही नाम सही गलत नाम Yeah, the library dot div files will be same which is defined in the folder, right? उसका भी mistake होगी तो वो उसको पिक नहीं करेगा ठीक है। Once you are all here, let me know. Or yes. Or exactly. Are you? So once you have this with the extension name also .lib ठीक है आखिरी में copy this path पूरा and go to your LT Spice to your symbol, right click here, go to attributes, edit the attributes over here and model file की जगह path को copy कर दें ठीक है। press OK. Now you have your path defined here, right? We want to use
तो save
अभी सेव नहीं करना। We want to use EPC 2010C सही है। So for that you can just change the name of it. Attributes पे जाके edit the attributes here and make it 2010C, capital C. ठीक है। Now you can save this symbol in your folder, right? Session 2 के अंदर I'm going to name it EPC 2010 capital C, right? हाँ। So now you have a symbol ID, right? Which is over here. Session 2.
तो हटा दो।
हाँ, you have a symbol ID. If you open this, you basically see कि your symbol is like this. Make sense? Now you can use this in your simulations. Let's create a switching circuit, right? Let's create a switching circuit, right? Let's create a circuit which turn it on twice, right? तो हम पास करते हैं Control N, Control O, Session 2 and gate circuit, or you can say gate circuit. Using EPC. Yes, सारे यहाँ पे आ गए। Now you want to create a turning on and off mechanism for the GAN MOSFET. Sir, check the VGS here. Open the data sheet of EPC 2010C. Yes. VGS, threshold voltage. What is the minimum voltage required to turn it on?
6 and -4.
That is the range. What is the VGS underscore TH? Are you all here? Adi and Aisha. 1.5, 1.4. 1.4, right? So it has they can use schematic and name it as follows: the gate circuit using EPC 2010C. Right? Gate circuit. So now we want to create a switching circuit which turns on or off the MOSFET, right? Not the MOSFET, hemmed, right? Call it hemmed. So press P and go to your location where you have the symbol. You can see that you have the symbol defined here. Voila, it comes over here, right? I just want to see कि जो उसकी data sheet में mentioned है हमारे पास about the threshold voltage, is it true or not, right? ठीक है? तो V uh, make some connection like this. जल्दी से. We are making a constant voltage sort of mechanism over here, right? Make sure that you basically need the schematic here. It's a constant voltage circuitry over here, right? And we have placed a resistor for the safety of the MOSFET, right? So it is a standard switching circuit over here. Okay. So we will see that how does the MOSFET turns on and off from this schematic. You want to define the voltage source over here as a pulse source because you want to give a pulse of 0 to VGS threshold voltage, right? So go to advanced and go to pulse here. Pulse क्या होती है? It's basically from 0 to 1, right? So initial voltage is going to be 0. The maximum voltage is going to be what? 2.4, right? 1.4. And T delay 0. To make it more realistic, let's make the T rise to be 1 nano and T fall to be 1 nano, right? You also want to define the duty cycle of it, right? So what is the duty cycle? ये कितने टाइम के लिए ऑन है, right? So for that I'm going to make it a 1 kilohertz की square pulse, ठीक है? So it's going to be a period of 1 millisecond and T on is 0.5 milli, right? So that means here it has a duty of 50%. Yeah, time delay 0 है. T rise, T fall क्या है? How much time it takes to rise and fall, right? To make it more realistic. Yeah. Done till here? Kadir? Aisha? So T period is the time for 1 cycle, right? So I want to make T for 1 kilohertz, right? So what should be the time period over here? 1 kilohertz. That is 1 millisecond. Okay. What is shown over here? It is the duty cycle of the pulse. So मैंने कहा about 0.5, which 50%. Make sense? Press OK. So this MOSFET can have maximum VDS of 200 volts. ठीक है? Maximum VDS of 200 volts. ठीक है? तो मैंने इसको दिया हुआ 120. So it is sufficient enough. सही है? It is within the limits. So let's make some nets here. So this is the gate voltage here, and this is your VDS. and this is your VGS. So we have grounded the source over here, right? So if you take the voltage over here, you below. Measure the voltage at this side over here. So source grounded है. So जो यहाँ का voltage है वो VGS है. So what is VGS? VGS is VG minus VS, right? By VS is 0. So if I measure as the gate voltage, that's my VGS. ठीक है? And this is VDS. Why? VDS is VT minus VS. By VS is 0, right? So if I measure as just the gate voltage here, then we have VDS. ठीक है? So if this MOSFET turns on, what should be VDS? If this MOSFET is, if this pulse is high, you switch on the MOSFET here. What should be my VDS? The pulse per shape. So it is 0 or high? Huh? 1 high. High 120. ठीक है. Let's see. But I also want to define my transient key settings. So press dot tran for 2 milliseconds, right? I want to show, let's say, 2 pulses. Right? So let's run this. This is my gate voltage here. And this is my VDS. It makes sense, right? Does it make sense? Let me see here. So what is happening over here is when this is on, when a VGS is enough to turn this MOSFET on, right? So this basically short, right? Asad, Adi, when this is basically high and the pulse is high over here, right? So this means the MOSFET on हो गया, right? So ये short हो जाएगा. हाँ, ये shows 0 volts. It shows 0 volts here. And this is off. तो जो सारा voltage होगा supply का वो यहाँ पे होगा, right? You see 120 volts here. It's a simple switching circuit over here, right? अब ये pulse क्या करने के लिए basically is making the circuit to switch on and off, right? You design it on from steps, right? How do we control the turning on, turning off mechanism over here? Does that make sense? So you have imported and checked the parameters also, right? So from the data sheet, what is it saying over here? It says it has a maximum voltage of VDA of 200 volts, right? So it is giving us 120 volts that works, right? 200 देंगे तो 200 देंगे. इससे ऊपर देंगे तो जल जाएगा, but in simulation it will run, ठीक है? But in hardware it will actually burn, right? ठीक है? So there is no stopping condition over here in the spice code, right? So यहाँ पे you saw the threshold voltage to basically turn it on is 1.4, right? 0.8 is the minimum over here. ठीक है? Let's see 0.8 over here. इस पे हो रहा नहीं हो रहा. Let's see 0.8. Let's see 0.8. ठीक है, it is switching on and off. ठीक है? At 0.8 also. हो रहा है? Switch हो रहा है? Is it working? Working for me. तो आओ.
इसी में एक मारा.
Why is my working? Let's see 0.4. इसमें ही चलेगा, right? ठीक है. So यहाँ पे बंद हुआ है, right? Circuit मेरा चल नहीं रहा. ठीक है, is not turning on off. You can see over here. ये हमारा voltage is 120 है, ठीक है? इसको जो भी कर रहे हैं, you can see the scale over here. 120 से 119.6 है. ये switch on off नहीं जाता. ये verify the data sheet, it is fine. And your model is also correct. ठीक है, this also. Make sense? Does that make sense? So you verify the data sheet on simulation. You imported the GAN model also, right? If you want to use the different model of GAN, change the name,
Change the
name of it. Okay. Let's try 500 volt. मैंने ट्राई नहीं किया अभी तक. Let's try this. Should not work. 400 कर लेते हैं. ठीक है. हाँ, it's not working, right? It blows up. You can see I can if it cross the radius rating, the MOSFET is not working, right? It's open, right? Not working. 380 volt charge should go to 0 and charge, right? Okay. So this model is pretty accurate. Gives you the realistic analysis over here and a good question. Okay. Make sense? So if you give the voltage which is under the rating, let's say 150, it should work fine. ठीक है. ये क्या आ रहा ये तो make sense? Yeah. अच्छा नहीं there is a drop over here. The drop over here. ठीक है. So there is some drop on the resistor जो plot देता हूँ. It should be triggering correctly. Let me just check it out. Let me give it 2 volts. ठीक है. तो 1.4 पे ये ट्रिगर नहीं हो रहा था. तो हफ्ते हो गया 2 पे. मेक इट 2. ठीक है. मेक सेंस. So basically, the VGS threshold is just the point when the MOSFET starts to turn on, right? So you have to give enough थोड़ा बहुत ज़्यादा voltage to completely turn it on, right? Or in triode region or in saturation mode, right? Make sense? तो अगर let's say इसके अंदर I increase the voltage to 400, ठीक है? So it would work, ठीक है? असद and हदीब, इसके अंदर स्टॉपिंग कंडीशन नहीं है कि अगर आपके पास वोल्टेज एक्सीड हो रहा है हमारे पास सप्लाई का, तो इट वोंट गिव यू अ प्रॉम्प्ट, राइट? इट वुड वर्क, बट इन हार्डवेयर योर आईसी वुड बर्न आउट. ठीक है.
मैक्सिमम ये कह रहे 2.5.
हाँ पे मैक्सिमम क्या बोल रहे हैं? 3.5. इसी थ्रेशोल्ड बोलते भाई. तो वीजीएस ऊपर है जो मैक्सिमम रेटिंग हमारे मतलब बोल रहा है कि इसकी रेंज द वीजीएस थ्रेशोल्ड की रेंज कैन गो फ्रॉम 0.8 टू 2.4 के बीच के अंदर, राइट? सो वीजीएस की रेटिंग जो एक्चुअली हमारे पास है वो ये. It is saying that the VGS threshold voltage can vary from 0.8 to 2.5, right? But the actual rating of the VGS, that if you cross it out, it would burn out, right? These are as follows: plus 6 max, negative 4 in the negative side over here.
तब भी दिखाया
क्या
6 लिखूंगा तब भी दिखाया
6 लिखोगे तो चलेगा. If you cross 6, simulation चला देगा, right? But in hardware, it will burn out. ठीक है? Make sense? So there are no stopping conditions over here, but the trends are almost realistic. ठीक है? Again burns out. ठीक है? Because GAN can trigger in both direction, right? If you recall, it can operate in positive sequence and also in negative sequence, right? Any questions now? We have learned many things today. Take a deep breath. Pause करें. ठीक है? Any questions?
आपका टेस्ट
कल मैं टेस्ट होगा आपका. We'll do gate driver circuit की लैब एक पूरी, ठीक है? That is based on PSpice, so we'll do it on LTspice on your own. जो पैरामीटर्स वहां पे डिफाइंड है वो यहाँ पे भी हैं सारे. you know how to navigate them. ठीक है? Make sense? You can revise the recordings before coming tomorrow.